I'd like to introduce our final speaker for this session. His name's Ian Rosam. Graduating in civil engineering, Ian gained 6 years of experience on UK highway design and construction before moving into the software industry. Now with over 25 years, various roles in infrastructure software with Moss Systems and Infrasoft and Bentley. Through his roles managing civil product management group, Ian has overseen product development and launch of Open Roads and Open Rail and has been involved in associated in-person and online engagement for Bentley for well over a decade. And more recently, Ian has been involved in more forward visionary role, focusing on digital delivery advancements for civil infrastructure with digital twins and AI. Very good.
Thank you.
Yeah, welcome.
I can tell I'm coming through on there. So first of all, thank you for the invitation. It's an honour to be here, and I've really enjoyed all the presentations so far, and the hospitality has been great as well. So it's good to stand up here and talk on this subject of AI. The main reason for that is I think there's a lot of misinformation and misunderstanding around AI as well. So it's an opportunity to sort of reset some of that and outline how Bentley perceived this in the industry and how we sort of focus towards it as to how it can assist in the industry. So what I wanted to sort of just run through, just as a brief introduction, and some technology trends that are underpinning and driving some of the things that we're doing, and then talk about some of the core principles around data and data governance and generative AI that we are trying to adhere to, that hopefully once we go through those slides, you'll understand why we want to sort of raise some of the concerns there. Then we'll just take a look at some of the current implementations that we have that really feeds into the opportunities as well for the industry. And we've seen a lot of those in action already with other presenters, so it's really good to see. So I wanted to start out with this sort of timeline around artificial intelligence, because I actually found it quite interesting when I was doing a little bit of research. And there's some key dates there. I'll let you sort of read through them. But I think it's very interesting that the Alan Turing sort of test that was introduced around sort of tricking humans into thinking they're engaging with another human in the 1950s. Now, that was around the same time that Isaac Asimov wrote I, Robot. And I think that's quite interesting. And you start doing the parallels with science fiction. And it was only until it was sort of later on the term artificial intelligence was introduced in, what was it? I think it was 56. So by that time, you'd got Arthur C. Clarke was in full flow with 2001: A Space Odyssey. So you've got these parallel tracks going on with science fiction. And the projection that they're giving, I like to refer to it now as Hollywood AI. This dystopian future that starts to get projected. And that's the sort of kind of, how should we say, it's a concern that people have in the back of their mind that Skynet is going to come real. So I find that quite interesting. But, obviously there's been progressions. The first chatbot, its introduction, I mean, we're all familiar with chatbots now. You can't phone through to a help centre without getting engaged with a chatbot these days. And we know it's a chatbot, but they try and pretend it's not a chatbot. So, but the early introductions of these, very, very basic. Now, there were some doldrums. It feels like there were some doldrums, but the technology wasn't there. The hardware is now present and available to do real-time processing against a lot of these things. So, I see some interesting trends that start to come out here. But what I thought was quite amusing was, who remembers this one? Yeah, good old Clippy. Now, there's some people in the room that weren't around for the introduction of Clippy, who was probably one of the most annoying additions that Microsoft gave us. But I think, if we start thinking about it, what was Clippy? Well, it was an assistant. It was an agent. It was trying to help us. Okay, it didn't do a very good job back in the day, but, the premise was there as to what Clippy was trying to do. So I think it's kind of interesting. And then we look back for the last 5 years, and since the pandemic, as to how we've all changed, and we've heard other people talking about this and the drivers for change, the acceleration has been incredible in the last 5 years. And I mean, this infographic that sort of I acquired here from InfoDiagram, I thought was fantastic. And it finished at about the right point for me in terms of what I was sort of trying to draw out here. Because it kind of leads into AI being thrust in our faces pretty much everywhere we look. My fridge is powered by AI now. Yeah, it's everywhere. And in 23, it was Collins Word of the Year. So it's everywhere. But going back, most people that aren't involved in it, in the general public, are influenced by media, by big corporations, and as I like to say, Hollywood AI, the dystopian future. So, there are some underlying concerns that stem from that. And generative AI is mainstream in a lot of other industries. We saw an example earlier on about a photo being generated with solar panels. It was generated by AI. So creative industries are using this as a regular basis. So infrastructure sector, though, it's a lot more conservative. It moves a lot slower. And that's sort of really the challenge that we face. How do we get that consensus that AI is going to impact in a positive way, and how can it help in that positive way? And so some research by Goldman Sachs highlights the AEC industry. It won't replace people. Now, we've just seen in the previous presentation about utilizing technology to actually provide safety features and not put boots on the track. And I think that's a great thing. We're protecting people, implementing safety processes. But there's alternatives and there's opportunities elsewhere. And that's the key thing that we have to think about, really. And that's really what it comes down to, is where Bentley agrees is we see AI as an assistant into many of the processes that we do, not replacing the human input, but assisting so that you do get the opportunity to evaluate more options and provide cost savings and redirect elsewhere. And obviously, demand, investment in infrastructure is growing. We've got complex projects. Crikey, we've seen some amazing projects with True and so on today. So there's a significant backlog of projects as well, although some may argue there's a slowdown as well. But what we are seeing is some significant problems in the industry in terms of we have not just an aging infrastructure, we have an aging workforce. We have a lot of people retiring, and retiring early on the back of the pandemic. Changing working conditions, people are changing sort of how they're engaging. So, there are challenges in that respect. We have problems with graduates and training programs coming through. So it's fantastic that we're here in the centre of learning and hopefully encouraging more people to come through. But ultimately, and it's coming out of UK Construction Skills Network, where they're looking at industry outlook from 24 through to 30 realistically. And they're basically saying that about a third of construction employers are finding difficulty in recruiting that skilled workforce. And they're projecting that they need an extra sort of 50,000 skilled workforce by 2030. So we're facing these significant challenges. So what we're trying to do to advance, actually, I'm going to back up here. Bentley's mission, I mean, we've been around for about 40 years now. We've just celebrated our 40th anniversary as a company, thanks to the founding family. But the mission that we've sort of been on essentially can be summed up as we're trying to advance infrastructure for a better quality of life. Now, you can interpret that in many ways, but we do see that AI plays an increasing role in that. So how can we resource the infrastructure industry to address some of those time-consuming tasks, make them more efficient, explore more alternatives and things like that. Get better insights. We've heard about insights and prediction and reduce risks and tasks. So this is essentially the fundamentals that we're trying to work to here. Now, one of the challenges that we face as an industry is the separate data sources that we have to deal with. Now, Bentley obviously comes from a desktop application as its sort of origin, and so we have multiple data sources that we have to deal with. But realistically, stepping back a good number of years, looking forward and having a forward vision, how can we make improvements and come good on that mission statement that we had about improving sort of infrastructure? And if AI is going to form a basis of that, then we needed to start with a foundation that facilitated AI. And we've heard instances today about the massive data that gets created and how much data is captured, and concerns on the amount of data that's being captured as well, capturing what's relevant and what needs to be acted upon. So there are all these challenges around data, and then how can we leverage that data ultimately for that source of intelligence? And that's the challenge that we sort of really face. So that's the strategy, essentially, that we've been trying to sort of work around for data, engineering data and AI. We have to deal with a diversity of data sources. There are multiple vendors out there. We are just one vendor. We have to interact. You have to interact with multiple vendors, and the data has to work together. There's different collection methods and different data sources, so interoperability and collaboration is fundamental, and that's a significant challenge. But again, we see this as an opportunity to leverage AI to sort of manage some of that data transference as well. Now, there are various initiatives that are in place in terms of international standards, future AEC software specification, IFC. There are lots of different standards out there, but those big international standards, they take a long time to get accreditation on and to actually come into production. So, this is a challenge that the industry faces as well. So, I'd actually say that Bentley are now well aligned to try and take on some of those challenges, because ultimately one of our core tenets has been about infrastructure digital twins as a general infrastructure digital twin, and our solution to try and solve that with iTwin, with our technology, is open source, making sure that that data is open and available and accessible so that it can be interoperable for other systems. And that's the iTwin platform that we've tried to implement and to provide that. Now, kind of a second sort of tenet there, or foundation really, is it comes down to how do you train an AI with these different industries and different segmentation of data? And that's another significant challenge. As we look at sort of power and utilities, bridges, roads, railways, geotechnical, structural, there's a lot of data. It's all in very, very different formats, and the engineering challenges are quite diverse with that. But at the end of the day, we have to be able to take that data and, in a generalized way, take it from domain specifics and utilize rules and logic that's associated with those specific domains to generalize and allow engineering applications and disciplines to interpret it and be connected. So this really comes down to a bit of a summary on those core principles that we have. Ultimately, how do you train AI? It's all about the data, the underpinning data. And one of the commitments that we're making, and sometimes this can actually slow things down to a certain extent, and obviously, if you start looking into how some of the large language models have been trained, it's questionable how they've been trained, and there are legal issues associated with that. So essentially there are three tenets that we have. that I sort of want to sort of really highlight here and sort of focus in on. That when we're utilizing AI in Bentley, you as the user retain control of your own data. You decide when and where it's going to be used for AI. Absolutely key. We are a software provider. We don't own the data. We don't have access to the data. So it needs to be done in partnership and in conjunction. So you, as the data owners, whoever the data owners, you have the final decision on that as to whether you contribute into that. Because there's questions then over who benefits from that data learning at the end of the day as well. There are concerns on the accuracy of that. We've heard that discussion earlier on. And it ultimately comes down to, if you create an AI model, you want to be in control of that so that you can actually qualify the results it's giving. Because you've got to be able to trust the results it's giving. And so that's really sort of the core tenets that we're trying to implement with our solutions. So I just wanted to sort of very quickly touch on a few of those solutions. We've seen similar things sort of earlier on today. I'm starting out with asset sort of analytics for sort of AI insights from an ALIM perspective, from a maintenance perspective. And that's really at the back end of the life cycle. Now, my background is design. So in design, the handover from design into construction, into ALIM, is very disconnected. And that's one of the things that I'd like to see sort of improved, really, is that handover of data through the processes. But dealing with that ALIM and consuming that model, it's a very different input. It's disconnected from the design and the construction. It's the as-built. It's constantly changing and evolving. And so this is an area where sort of we're using sort of analytics to sort of look into that data in specific use cases. And a lot of it comes out of research. So here we have an example with Blinksy, which I think I'm right in saying is based out of Salt Lake City in Utah. And it was a combined research program with Utah DOT, I think. But it looks into sort of road analytics and monitoring, real-time detection of assets in the field. We've seen other examples of doing this. And from a robotics, if you've had a wander around on the floor out there, the robots are doing that as those analytics. But obviously there's a large amount of crowdsourced data that's available and that can be drawn in and learned from this. And the potential here in terms of asset management of other linear systems than road networks is obviously there. And so this is something that is actively being pursued as a productization and certainly is looking into other industries as well that it can be applied in. Another area, and again, coming from a research background, and this example is Benesch in the US, is about sort of crack detection. And so this could be crack detection of pavements. It could be a bridge inspection. The video obviously here is of a runway. But what we're dealing with there is a combination of multiple data sources. It might be photogrammetry. It might be LiDAR scans. But resolving those down together from a 2D and 3D, identifying cracks that we can measure and do analytics against, and actually then projected maintenance programs as well. Open tower is another one. Sort of transmission towers, telecommunications, another one where there's collaboration problems, should we say, access to data, problematic locations, so challenging to get into. But this is where a drone scan, for argument's sake, could be used to capture photogrammetry and LiDAR information combined into a 3D model. And then with AI and learning, identify assets and deal with sort of potential maintenance problems as well. So addressing those challenges. But looking a little bit further ahead, design, how do we address design and how can we sort of influence from a design perspective, not just from an ALIM? And so this is where we're in the process of our first kind of ground up. So I've got 5 minutes, thank you. First ground up design application as to how this can help. And it's really to try and address some of those concerns that I raised about the industry in terms of problems of skilled labor, number of projects that are available and things like that. So allowing organizations to progress their designs more efficiently, evaluate more options. And so this is our sort of first implementation of a ground up. It's based on the iTwin technology, where we have a large language model integrated into the design application itself. So it can be exposed to the project specifications and information that are drawn along with the project. So you can engage with it and ask it questions in terms of, in this instance, it's looking at specifications on zoning and whether it's permissible to actually put a site layout in this location. Obviously, combining it with the manual CAD tools and drafting solutions. But these are sort of parametrically designed so that we can automatically sort of optimize design layouts. We can then engage with it through the LLM to actually drive it. So we can look at it in terms of the parking bays. Yeah. Have we got enough parking bays? Count them for me. Change the angle, change the depth of them, change the width of them. I wish we'd changed the width of parking bays in the UK and make them bigger. Nobody can park in a parking bay in the UK. But we start to introduce this as a means of providing assistance to the engineer. It's not doing the engineering, it's providing assistance to the engineer. And this is where we get into the realm, realistically, of allowing the AI to optimize the design, to look at the grading model, run through iterations, trying to achieve an outcome, and then offer that up as a design solution for the engineer to validate and sign off against. So, these are all tools that are leveraging AI to provide assistance to accelerate the design process itself. Obviously, type control, voice control, it's going to get interesting in a design environment for that, and thankfully we're not quite at the realms of Minority Report and all juggling around, but it may well happen. Other aspects that we're extending this with, another pain point in terms of the deliverables, drawing production. So AI-driven drawing production, optimizing sort of annotation layouts, positioning of text, that are very manual processes to sort of optimize sort of white space layout and things like that. So it's an area that we're sort of actively pursuing to drive into the AI world for the design solutions. So just sort of wrapping up, and I'll just touch very briefly as we're sort of out of time now, on opportunities. And we've seen a lot of these in the examples that we have, and it's really sort of from a rail perspective, and I tried to sort of draw some of the rail opportunities in here from maintenance, and we've just seen some fantastic examples sort of this, and I'm just sort of really sort of summarizing in terms of that crowdsourcing of data and data collection, myriad of ways it can be collected from vehicle-mounted equipment, aerial equipment and scans, looking at vegetation growth. Obviously, inspection. We've just seen the importance of geolocation and how that can be managed. So there's an incredible amount of opportunity here to serve up information for and solve a specific problem. So I think this is an amazing time to be in the industry to facilitate these types of things. We have here an example of, and this is Transport Sydney Trains, so down in Australia, but visualizing their digital twin. And I never really sort of delved into, everybody has a different interpretation of a digital twin. There are lots of representations of a digital twin. So here what they're doing is they're looking at their assets with a myriad of different information and a different sort of lenses that they can turn on to change the perspective as to what they're looking at, planning, maintenance, tracking work that's being done. So the amount of monitoring that's being done and facilitating sort of maintenance and scheduling is quite incredible. And this is, again, it's through collaboration on an open source platform with the iTwin technology. So again, I'll just sort of skip forward here, but again, this is sort of like predictive sort of forward planning, tying it in with sort of weather conditions and predictive maintenance. So I know we're at the end. So really I see sort of the innovation that's going on is happening with everybody that's in the room here. Rail operators have the data, and so it can facilitate a lot of the innovation that's going on and solving particular problems. So, I think as I say, there's a great opportunity here that we can be part of that journey in terms of facilitating with an open data source that can tie into standards and can connect different data sets and different vendors and facilitate some of this collaboration that needs to go ahead. So with that, I'll leave that with everybody in the room. Call to action on how you can facilitate that change. Thank you.